we are working on what we did last time, which is finding the slope of a tangent line exactly. And there are two formulas that you can use. This one is the limit as x tends to a, and that, when you eventually finish, is typically a number, and that number is the slope of the tangent line at whatever the given point here is. And this other function also does the same job. And I believe yesterday I went and said to you that the reason we typically have two is because one formula is better in certain circumstances than others, right? It's just algebraically easier. You should use this guy when you're doing things with square roots and fractions typically. And you should use this guy when you're doing polynomials. Well, this counts as a polynomial. But in question 3, you're being asked to find the slope of the tangent line using this formula. And then you're being asked to find it using that formula. And I think the reason they're doing that is just to show you, one, that both work, right? They both end getting you the same number, right? And probably that you'll also see that this one is ugly and this one is easy, right? In other words, algebraically, this one's easier to do the answer than this one, right? Now, if I had enough time, I will do both. But since I don't, I'm only going to do one of them and say to you, you can try the other one, you'll find out it works exactly. You know, you get the same answer at the end, even though the algebra is quite different to get there. So do you want me to do the top one or the bottom one for this question, since I only really want to do one?
Bottom one.
Bottom one gets the job, okay. I'll keep this here because that way I can have these two formulas. So I'm going to find f dashed of -1. Do you see that this here is the x coordinate? And that's the number that we're calling a in the formula. So it's going to be the limit as h tends to 0 of f of a plus h, take away f of a, all divided by h. In this case, it's going to be the limit as h tends to 0 of -1 plus h, take away the value of the function -1 over h. Right, x squared plus 5x. If you want to find the value of the function f at this point, you replace the x's with -1 plus h squared plus 5 lots of -1 plus h, take away, and the value of the function in -1 is what? -1 squared, add 5 lots of -1, 1 take away 5. This is equal to -4. What you can then do is FOIL that all out. And if you do, you get -1 squared, which is 1. You have two terms in the middle that combine to give you that, and you have an h squared. If you distribute the 5, you get a -5 plus the 5h, and this guy ends up being add 4. And then you can collect like terms. And what do we get? That guy, take away that guy, add that guy, gone. We have an h squared, and when you combine these two, you get plus 3h. Have you noticed the numbers always kill each other off? I said that yesterday, but that's a good place to pause, because these can be quite ugly, right? There could be a lot of algebra, a lot of foiling, right? There's a chance you might have got a +2 when it should have been negative. So when you get to this line here, you notice that they're only terms with at least an h in them. That's a good sign. If you have a +3 or a -2, stop, you're wrong. Figure out what went wrong before you move on. Now, the end of this question is pretty standard. Don't you just pull out a single h as a common factor? Even although you could do more, you know, you might sometimes be able to pull out 2h as a common factor. Don't, just pull out an h. And then you can cancel the h's. And what you're left with is a very simple limit. The limit is h tends to 0 of h plus 3 is 3. So we now know the slope of the tangent line, oops, f dash, the slope of the tangent line at -1. And if I had chosen to do the top one, can you trust me that it would still be 3, right? When I finished, that would be the same answer. It's the same thing you're finding, but it would have been 3. They also go on in some questions, and this is one of them, question 3 does this. They ask you for the equation of the tangent line. Okay, now I know the point on the curve. It was -1, -4. I know the slope of the tangent line. It's 3. Okay. Can anybody remember the formula that you use to get the equation of a line that passes through this guy with a slope of that? Can you remember what the formula looks like? Because that's what we're going to use. Any volunteers?
You mean the y-x, or sorry, y equals mx plus b, so.
Well, that is a general version,
Fine.
but in this case, it's y take away y1 equals mx take away x1. Do you remember that guy? Now, the guy that's called x1 and y1 are these guys, and that's obviously 3. So what you've got now is y take away -4 is 3 lots of x take away -1. And this will give me the equation of the line passing through this point with a slope of 3. So it's going to be that y equals mx eventually, but not yet. Distribute the 3 and then subtract 4 from both sides. And that is the equation of the tangent line. So I'm going to actually see if I can prove that this worked. We're going to do the original curve, which was what? What was that curve look like? Yeah, the original curve was y equals x squared plus 5x. And at the point -1, -4, it had a slope of 3, and the equation of the line was that. So I'm going to put that into Desmos, and hopefully we'll be able to see it and convince ourselves it worked. I'm still loading it up, that's why I'm still here. There, yeah, almost done. Desmos. I've learned in the past that you have to have it loaded up before you change screens, or it can't find it. So you could do this as part of your homework if you wanted to check. You could certainly do it in a test. So I'm putting in the curve, which was y equals x squared plus 5x. Yeah, pretty standard looking thing. The equation of the tangent line was y equals 3x take away 1. Now, if I move this guy and maybe zoom in a little bit, maybe it's too much zooming in. There, can you see the point -1, -4? Do you see it there? Would you agree that that blue line is a perfect touch on the red curve? That's what a tangent line looks like. Do you see that we found it? Now, if I zoom in ridiculously close, can you see you can't tell the difference between the two now? Isn't that a good sign it's a tangent line? If it missed it, wouldn't there be a tiny little sliver of light between the two and you'd say, ah, you missed it, right? But you can see that one is so close, it's on it, right? It's a perfect tangent line. So if you were wanting to check, have I done this correctly? Couldn't you put in the equation of the original curve and the equation of the tangent line, and shouldn't they match exactly like this did? Now, let's pretend, not that I've ever done this, that I made a mistake and I thought it was 3x plus 1. can you see that doesn't look like a tangent line anymore? You know, you can just visualize it. At that point there, would you agree that this blue line isn't even near it? I don't think you can pick lines up. No. I can do coordinates. Let's put the right one back in again then. That was the correct equation. Right, if I take this guy, or at least there we go. There. Can you see that's pretty much -1, -4? And that's the check. Any questions about that? Right. So if I give you a reasonably nice curve, something that's not too ugly, could we find, using this formula, the slope of the tangent line at any given point? And if we had to, couldn't we sometimes, because they don't always ask you to do this, couldn't we also find the equation of the tangent line if we needed to? Okay, another one. Make this go away. Desmos. Okay, where are we? Hold on a second, I'm trying to find my questions here. Gotcha. All right. Here, let's do a version of, let's do a version of question 5 then. And we have y equals 2x squared, take away 5x, add 1. And we're interested in the slope of the tangent line at the point 4, 13. And then after that, the equation of the tangent line. I'm not going to do part B. But let's do that guy. So we're going to find f dashed of a, right? And that's going to be f of x, take away f of a, over x, take away. And in this case, the a is going to be 4, right? That x coordinate. So it's going to be the limit as x tends to 4 of f of x, which is this guy, take away f of 4, which is 13, all over x take away 4. And this fella is 2x squared, take away 5x, take away 12, and it's over x minus 4. To do these ones, don't you have to factor the quadratic? So this is going to be factor and cancel. Since this is 2x squared, I know this is going to be 2x and x. Give me some combination that works here.
2x plus 3 and x minus 4.
Nailed it. Any shortcuts that you used, or did you just do it, until you got it right in your head?
I was pretty sure one of them was going to be x minus 4, and then
Correct.
I just figured one out.
That's exactly what you should have done. Do you get Alison's logic there? For this to work, doesn't the bottom guy have to be a version of x minus 4? Because isn't that what's going to happen? So even if the quadratic is ridiculously big numbers, like making some up, 50x squared plus 120x minus 70, isn't it going to be 4 times something, right? So you already know one of them's x minus 4. It's a little bit easier, isn't it, when you know one of them to do the other, even when the quadratic's ridiculously ugly. And of course you can cancel. And now you have got the limit as x tends to 4 of 2x add 3. And we can do that by simply just plugging in 4. And I believe the answer is 11. So the slope of the tangent line ended up being 11. And then you can do other stuff after that. You like? Okay. Let's do a fraction and then a square root. Go. So I'm going to do a question where the function is rational. It's a fraction. And then I'll do another one where it is the square root. And okay, let's go for it. The function that we're going to be using is this guy. And it's going to be at the point 4, -7, okay? And I'm going to do the limit as x tends to a of f of x, take away f of a over x minus a. Now, I could have done this guy here, right? Oh, sorry, this guy here, right? Eventually it would have worked. None of the two methods is going to be anything nice, but my opinion, this is nicer, right? It's both are horrible, but the other one's really horrible, okay? So you might look at this and say, God, that was horrible. Will you trust me? The other one's even worse, right? So, but you pick what you feel like. If you want to do it the other way, go ahead. So it's going to be the limit as x tends to 4 of f of x, take away f of 4, all over x take away 4. And that's going to be x plus 3 over x take away 5 minus, plug that in, it's going to be -7. Actually, I know that that guy isn't it this guy? So I didn't need to calculate it at all. I'm only putting this line in for neatness. There's nothing much happening here. You are looking at some heavy duty algebra here. Somehow or other, we have got to take this top line and make it so it's not a fraction anymore. This is like the ultimate version of horrible, right? And we know how to take care of fractions. Don't you multiply the top and bottom by a special version of 1 that takes care of this fraction, really? What version of 1 is going to take care of this guy? What takes care of x minus 5?
Would it be x minus 5?
Yeah. Haven't you normally just needed to do top and bottom by 2x or top and bottom by x, right? That was fractions as well, but they were relatively easy. Can you see how this one works? It's x minus 5 top and bottom. Now, what's going to happen is that each term, there's 3 of them really, get multiplied by x minus 5, and that should, if we do it correctly, that should make everything come out nice. Well, let's do the easy one. This guy times this guy is just x minus 4 times x minus 5. And I know there's a temptation to FOIL that out, but never do it. Just leave them alone. It's better to leave them alone. Now, what about this? Oh, I should write it over here. What would happen when you take this ugly term, right, this guy, and you multiply it by an x minus 5? Something really nice happens. Don't they cancel out? And the answer is just x plus 3. Yeah. So this guy times him is just x plus 3. And the 7 times him, well, you get 7 lots of him. So we now have the limit as x tends to 4. Leave the bottom alone. And I'm going to do this in 2 goes. 7 times x is 7x plus 1 more, 8x. 7 times that guy is -35, add a 3, -32. You okay with me doing that in 2 goes around having to write 2 lines of work? Right? X adds 7x, 3 minus 35. We're almost there. I want you to look at the top. It's all about what's happening on the top. Is there anything you can do on the top here to make it look prettier? And I see a node of Rachel, so I know one of you can see it. I see a lot of because you can now cancel. And what you're going to be left with? Well, it's going to be the limit as x tends to 4 of that. Of that guy. Almost got it wrong there, right? 8 over x minus 5. Now I can plug in 4. That's a long wind. Right. Then we get a slope of a tangent line is -8. That's cool. Now, they also want the equation of the tangent line. So I'm going to do the y minus y1 equals mx minus x1. That's the slope of the tangent line. And this is the point where it passes through. So this is the x1, y1 that we're going to use. So it's this guy, take away -7 is -8, x take away 4. Y plus 7, -8x add 32. Y is take away 7 from both sides and you get that. And that is the equation of the tangent line at this point.
I had a question.
Yes.
It's on the left side page where you
Okay.
have the arrows. Where
Yes.
it says f of x minus f of 4. How did you get the 7?
Oh, how did I get the -7? Right. See, it's take away f of 4, so it's take away -7. I could simply just go up here and say 4 add 3 on the top and 4 take away 5, and that would get me 7 over -1, which is -7. And I'm just saying that guy there's the same thing as the value of this function at 4. So it's just less work if I just say, oh, I know that guy's going to be m. And so that's kind of where that happened. So take away that value is take away -7. So see if they said this was 4,3, I'd just say take away 3. If this was 0, it'd be take away 0. If you don't like that, just plug it in and get the answer the usual way. It'll still be the same number as here. So it does work. Oh, can you imagine a different world, right? Could have. And this was what we got on the top. Just for argument's sake. That could happen, right? Am I allowed to cancel? Can I cancel 4 minus x and x minus 4? What happens when you cancel 4 minus x and an x minus 4? It's not 1 that's left behind. What's left behind? -1. So won't your answer be basically that? You see, there's not an awful lot of difference, right? That's pretty much it, isn't it? You either get a nice cancel or you get a cancel where you might have to stick in a negative because they kind of reverse themselves, right? But if you do it correctly, this always happens, right? It's not, oh, that was just lucky. No, it always happens. The guy on the top will cancel one of the guys on the bottom. Any other questions about this one? Would you agree it was ugly? Do you want to just agree with me if you tried the other method, it'd be even worse, right? If you've got time, try using that formula. Trust me, it's even uglier. And now I need to find the square root one. Oh, it didn't take me long. The function that we're going to find the slope of the tangent line, yikes, that is an ugly number. And the point is at -1, -8. And we are going to find the slope of the tangent line, f dashed of -1. And since it is a square root, I'm going to do the limit as x tends to a method. In this case, A is -1. So it's going to be the square root of 2 take away 62x. Yikes. And the value of the function at -1. What is the value of this function when x is -1? And you can actually do it without calculating.
Is it 8?
It's 8. That was that thing I was talking earlier about, right? And now you can do it. You can say 2 take away -62 times -1, 2 add 62, 64, square root of 64 is 8, right? You could do it that way, or you could just use that guy. And taking away a negative adds 1. So we're now looking at the limit as x tends to -1 of, oh, I guess I'm just repeating myself here. Don't really need this line, but it's too late now. Remember that funny name for this technique? Starts with a C. What am I going to do here?
Conjugate.
Conjugate method.
And exactly, isn't it the same two guys, but with a plus? And so the square root of 2 take away 62x plus 8. The square root of 2 take away 62x plus 8. And the bottom two terms, you just write them down. X plus 1 square root of 2 take away 62x add 8. Now, when you multiply this guy and that guy together, you can do the foiling, but there's actually a shortcut. Do you notice that these two things are difference of two squares? It's like A take away B and a times A plus B. Do you notice it? What that means is that all you get when you're finished is this guy times himself, which is 2 take away 62x, minus this guy squared. The two terms in the middle always cancel out. So I'm now looking at the limit as x tends to -1 of this ugly guy and on the top I got that, take away that, and I am looking at -62 minus 62x. Nothing has gone wrong. Everything is perfect. How am I going to fix the top line?
What
Right,
happened
right,
to
62
the
means-
2?
Say, question?
Oh, what happened to the 2?
Oh, that 2 there, take away this 64, became -62. How am I going to factor the top?
Just factor out 62 or -62 and cancel.
Would you agree that -62 would be a much better choice? Agreed? Now, do you notice that the top says 1 plus x and the one underneath it says x plus 1? Isn't that totally okay? Right? Aren't they the same thing? So when I cancel them, they just cancel out, right? They don't change anything. So we now are left with the limit as x tends to -1 of this guy all over that guy, right? And now I can plug in -1. So I get -62 on the top. I get the square root of 2 take away 62 times -1, add 8. I'm running short of room here. So these two guys multiplied together are positive 62. 62 add 2 is 64. The square root of 64 gets you 8. So what we have is -62 on the top, 8 add 8. -62 on the top, 16. Will you write that down in WebAssign as your answer? Can you do better?
vector or reduce.
Okay, and if you divide top and bottom by 2, would you agree that is now the best that that number can be? So, you know, if you put in this into WebAssign, it's probably going to say you're wrong, because this is what it was expected. And we assume that you're going to do that. Also, never turn any of these questions into decimals. So don't call them 1.234. The only time you would ever do a decimal question is if you're in WebAssign and it says to 3 decimal places, right? If it phrases it like, find the slope of the tangent line correct to 3 decimal places, then you can start hitting buttons on your calculator, you know, and give me that as a decimal. Otherwise, everything has to be an exact value. So that's the right answer. Are we good with that question? Is there anything you're not sure about?
I'm still confused on the how it's 2 minus 62x and then minus 64, how that turns into negative 62 minus 62x.
Okay, so we're talking about this line here. So we have a 2, take away 62x, take away 64, right? That guy? Right, if I rearrange the order, it's that guy. That is negative 62, and that's what he always was.
Oh, so it's not in brackets.
No, it's just rearranging terms. And the brackets were just there for emphasis. They don't need to be there now. So when I took them off, did it make it a little bit clearer what was going on? Right. Any other questions? Okay, I think we should do another one of the general ones. Now, the general ones are the ones where you do A's all the way through. So let's do another square root. The function's going to be 2 square root of x, and we're going to do it to x equals a. And I'm going to do the limit as x tends to a. So we call that f dashed of a, that represents the slope of the tangent line at x equals a. And I'm going to do this guy again. And the reason I'm picking this one is it's a square root, right? If it was a fraction, I'd pick this one as well. If it was an x squared something, I would pick the h one, and that would cover it. So it's going to be the limit as x tends to a of f of x, which is this guy, and f of a, which is this guy. So far, so good? Right. Now, I'm going to put low brackets around, guys. Do you recognize that this is a conjugate? And the conjugate of this guy is 2 square root of x's plus 2 square root of a's. Are we good? Now, if you multiply the top 2 terms together, you will eventually get, I'll write that down in a minute. Let's just put these guys out the road first, right? If you multiply this by this and you do FOIL, you get 2 of these times 2 of these, which gets you 4x. Take away 2 of these times 2 of these, which gets you 4a. The 2 terms in the middle, one's a plus and the other's a negative, they kill each other off. That's why there's only 2 terms here at the end. I'm doing the same algebra that I did when a was a number. I'm not changing anything significant. Can you tell me the top row now what I can do to make it look pretty to help us with the next step?
You can factor out a 4.
And in this case, hey, magic, you see it? Oh, cancel, cancel. That means we're now looking at the limit as x tends to a of this. after you've done the cancelling, whatever is left, you should be able to just replace the x with a and you're finished. Of course, that doesn't mean there might not be some ugly algebra to take care of. But right now, when you replace the x with a, that's what you get. Great. Now, the ugly algebra is coming up. Is there any way to make the bottom a little bit prettier?
Combine the like terms, so it's 4 red A.
Is there any way to make that fraction prettier?
You can rationalize the denominator.
Oh, that's a cool idea. Before you keep that thought, I like it. Is there anything you can do before that?
Cancel the 4s.
And then let's do that, rationalize the denominator. I never thought of that, but that's actually kind of cool. Wouldn't that be our answer? Now, if someone then went on and said to you, I would like to know the slope of the tangent line to this curve at x equals 25. I don't need to do anything because I already know that the slope of the tangent line is this guy. So won't it just be the square root of 25 over 25, which is 5 over 25? Won't the answer be a fifth? And if somebody says, what's the slope of this curve when the x coordinate is 100 or 9 or 42.1234? Can't I just use this formula here and I should be able to evaluate the slope of the tangent line at any point? So if you know f dashed of a, which we do, isn't that enough to find every slope of every tangent line on that curve? All you need to do is tell me who a is and I can figure it out. Would you agree that's a much more efficient way of tackling this problem? Instead of having to do the exact same working, but with a equals 10 and then equals 2 and then equals 7, right? Have to repeat yourself every single time they keep changing the coordinate. I'm trying to sell that this is a good thing to be able to do, right? Any questions about that one? Are we good? Okay, last question for today. So while I'm getting myself set out, say your last name. And we're going to do a version of question 10. In this case, the cliff diver plunges from a height of 25 feet. 25 feet. There he is. Whee! Plunges from a height of 25 feet. And the distance the diver falls in t seconds is given by this formula. The distance that he has fallen in t seconds is given by the formula 16 t squared. And if you want to know the units, they are feet. And it says, which equation would you solve to find the time in seconds until the diver hits the water? And there's the C, right? And it gives you a list of equations. Which one would you use? If I said, how long does it take him, right, to hit the water? How would you do it? Don't need the answer, but just the equation that you would use to do it. Any suggestions?
Is the feet, is that an empty variable there?
Is this 25 feet or this feet? What are you
Well,
talking about?
The equation is,
yeah,
the whole,
to me, I wish that wasn't there. It's just a distraction to me. right?
Okay.
The answer is in
So-
feet, right? But the T looks like time, and that's annoying. So I'm pretending it's meters or any other unit. So the question was, how would we find out how long, the time it would take for the guy to jump off the cliff to hit the water, if you know the distance that he has traveled at any given time T is this?
Okay.
Here it goes. Anybody before I write it? Aren't you trying to solve? When is that guy 25 feet? Agreed? That's what I was getting at. So it's probably the way I phrased it. So let's find out how long that is. Wouldn't you divide both sides by 16? And then wouldn't you take the square root? Now, technically speaking, when you do square roots, isn't there a plus minus choice? Why am I only picking the plus in this situation?
This time can't be negative.
Yeah, unless you're Doctor Who, right? If you know what I'm talking about, you can't change time in a negative way. So that would end up being 5/4 of a second. So now it asks us, next part, to find the velocity. Now the velocity is the slope of the tangent line. You may or may not know that. It's the rate of change of distance with time. So I need to find out what that is at t equals a. Now I've run out of time here, so I'll just set up how you would do this one. They even tell you the formula to use. So it's going to be the formula a plus h, oops, take away a all over h. So you are going to do 16 lots of a plus h squared, take away 16 lots of a squared over h, and almost forgot the limit as h tends to 0. And if you do this correctly, you're going to trust me on this one, it ends up being 32 times a. I know the answer because I know the shortcut, and you will know the shortcut by tomorrow. 32a. So what speed, what's his velocity when he hits the water? Well, that guy is the value of a, right, when you hit the water. So it's going to be 32 times 5/4. He is going to be doing 40 feet per second.